much better. Okay. This is chapter 13, network protection systems. We've actually talked about a lot of this already, so we're going to cover some of it in more depth than others. We're talking about ways to protect your networks. Okay. Years ago, we had no networks, so no big deal there, but now we do have networks. Okay. And they call it unified threat management. It's it's using components to protect your network. Pretty basic stuff there. Tell them what a router is. If we have routers at our houses, we all have routers. You probably might not realize you have a router. It could be provided by your ISP, but you have one. It's a way of connecting your internal network to your external network. Okay. So as a user send packets to different network segments. There's different protocols they use, and they have link state, they have distance vector, they have different protocols that, let me give an example of the work. RIP, for instance, Routing Information Protocol is one of the protocols. RIP, I might be off slightly here, but RIP would broadcast all the routes it's aware of to all the other routers every 30 seconds. So in other words, if I'm a router connected to a network, I would broadcast to other routers and say, hey, I know of this network and this network. I'll do that every 30 seconds. Is that a lot of...
Sounds like a lot of information.
It does, but it would be updated quite frequently that way. OSPF, for instance, Open Shortest Path First, would basically tell you shorter ways to get there. It's like, this is how many hops it would take to get to such and such a place. So there's lots of different protocols in there. And, depending on what you use, there's just a bunch of them out there. You have to figure out which one's best, do your research on them, and go with the one you think does what you want. Cisco is probably one of the most popular, but, do you have to go with Cisco? What's the one that begins with P? Anybody?
There's Huawei from the Chinese.
Oh, there's a new one local. It's
There's Juniper.
Juniper, and there's one more.
There's Sycamore.
No, that's not it. There's one more. The reason I know is our career tech advisor lady, her husband works for him. I can't think of the name. Well, there are a lot of different companies. They all pretty much do the same thing. According to them, they each do better than anybody else, but it really depends on what you need. Rose State, we currently use Cisco products. But does that mean we have to use Cisco products? No, we could switch to someone else, and at some point we might. It's kind of like, we use D2L. Well, next semester, no more. So, we're using Canvas school-wide starting next semester. So really a router is just a piece of hardware made by a company. Now Cisco, I was actually talking to our guy who manages all of our network devices today. And they got a new policy with all Cisco hardware. They no longer repair it. What you do, you just send it back and they ship you a brand new one. Rather than send it in and get it fixed, you just send it back and they send you a new one. It kind of makes sense rather than, trying to figure out what's wrong with it, repairing it, or send someone out to fix it. So kind of a cool deal. This is millions of people, and they bought out Linksys years ago. Because Linksys was a great company. Then they started to suck. Then Cisco bought them out, and they actually got better. And I don't currently use them, but they're still out there. It says vendors offering competitive products often design their configurations and interfaces similar to Cisco. So if you learn any of the iOS commands, you're probably going to be fine. Okay. Then they do say here vulnerabilities do exist. Okay. Vulnerabilities are everywhere. I don't care what system you have is vulnerable in one way or another. Okay. Cisco has RAM, and has non-volatile RAM, and also flash memory. Okay. They store the OS itself. They store your access list. It says here, hold your router configuration, routing tables and buffers. It holds the router's configuration in the NVRAM. And iOS, the routing is used in flash memory. So, different places to store it. Also, read-only memory. That's what it boots to. Okay. Then on the shroud, you have interfaces. You might have, gigabit interfaces, or 100 megabit, or we're actually looking for our new lab. We're putting in 10 gigabit interfaces. So what do you think? Is that good enough, you think?
Probably.
Yeah, I'm thinking 10 gig is probably sufficient. So, you
At
know.
the moment.
Exactly. So, really, you need different interfaces. And, you know, we're having an issue right now in the CyberLab network where we're limited to 100 megabytes, which a few years ago was good. But now, 100 meg is nothing.
That's not shared between the whole network, is it?
Yes, it is.
And yeah, that's not.
What's happening is Brad found the part causing the problem, but you're always limited to the slowest interface on your entire network. And there's somewhere between our router and our switches and our transceivers that one of them is a 10 megabit or 100 megabit one. So I don't care. We could have gigabit internal, but external we have 100. It's like I can download a file from the internet in my office at gigabit speeds. To copy it to this PC right here takes 10 times longer. I mean, we're literally copying from that end of the hall to this end of the hall. Why would it take that much longer?
There's a slow interface somewhere.
It goes through this darn phone, and this is a 10 megabit connection. Is it 10 or 100? It's either 10 or 100. But I have 100. I'm not got a gigabit connection to the internet, but I have a 100 megabit connection to the phone, you know, into here. All the computers in this building, well, majority have, what they do is to save ports, they have the wall port, the wall jack going into the phone, then the phone into the computer. So we're kind of limited to 100 meg, which sucks, okay? I had 2 ports in my office, so I had to enable both of them. So my phone's in one, my computer's in the other. So faster that way, so it works much better. So, all right, in our routers, those of you in forensics already should know at this point that the online password was actually connected into a Cisco router. Does everybody realize that? Those of you who did that project. So you have user mode and then privilege mode. Privilege mode is where you can really do more stuff. It's called privilege. I don't know what to call it. Administrative privilege. It's kind of like a domain admin level on the router. Okay. User mode, you can see some stuff. You don't change anything. Privilege mode, you can actually change some stuff. Okay. The router says you have global configuration where you can configure the entire router. Then you can also configure specific interfaces. Now, if you think about a router connects to different networks. So these interfaces need to be what? They need to be on different networks. So you configure one interface to be a one IP address, a different interface to be a different IP address on a different network. And the router's job is zero between them. Okay? Pretty simple stuff there. And here's some of the commands. You know, show version, show IP routing, show interface, show flash, so on and so forth. Show run, there's just lots of different things you can do. You can also just type a question mark, and it'll show you the commands. Or you can type show question mark, it'll show you all the sub-commands below show. Cisco's pretty simple to use, it's not hard. Okay. So several types of access control lists. We use an access control list, think of it like a firewall. We have a standard and extended access control list. When I ran my ISP at my house, Cox provided me with a free router, which I'm like, sweet, that's awesome, save me some money. So they were out connecting my network that day, and they brought me my router. I said, okay, thank you. What is the command, what's the password to get into the router? Oh, we don't provide that. I'm like, I need it. I need to set up my access control list. And like, oh, can't do that in our routers. Well, what the hell good is it? It's literally just a router. There's no security configuration available. So that literally lasted that day. So literally the moment I went online, I bought me one, I had it overnight shipped to my house and replaced the router with another router nearly instantly. So I mean, it's kind of like, yes, we're selling you this building. Oh, but there's no locks on the doors. That kind of sucks. So, all right. Here's a picture one. A standard IP or access list that says can restrict IP traffic leaving or entering. I can block specific addresses. Let this guy in, or let this guy out, that kind of stuff. I can also permit any, I can deny all, I can do whatever I want to do. Okay. That's an example of it. Okay. Now, extended access list, now I can get particular. I can say, allow traffic from this address to that address, running a specific protocol, running on a specific port, stuff like that. So I can allow port 80 in. I can not allow port 53 in or whatever, So you really need a mixture of both of those. Okay? And they're pretty simple to configure. Okay? If you don't know how to do it, obviously Google has plenty of examples. Okay? But I will tell you, word to the wise about doing this, do not ever configure them remotely. I ran my ISP for many years, and I did a lot of the work from here. So I would remotely get into my home routers, into my home network and do stuff. Well, I had to change my access list. It's a little bit different now, but in the past, the way you did it was you would remove your access list and apply the new one. It was basically remove and apply. I mean, it's literally copy paste done. Or it was cut paste is what it was. So I was all ready. I had the new one all written. I had it all copied. I was ready to go. So I hit cut, and guess what happened? Totally, I was gone. I was denied access. I'm like, oh crap! My entire network went down. Oh, that sucks. So I had to run home real quick and hit paste. I'm like, oh, that sucked. So yeah, not a good plan. So you gotta be careful doing that stuff. But you only make that mistake once. Just one time is all it takes. Luckily, we're talking, 15 minutes away. It's not like it's in Dallas or something. Okay. Other firewalls, the type of devices, with embedded OSs. There's actually, you can buy a SonicWALL. SonicWALL is super easy to set up. We also have one called IronPort here. That's our mail firewall. But SonicWALLs, man, I'm just really impressed how easy they are to use. Okay. Hardware advantages, it's usually faster than software because that's its only job. It's usually quicker at doing it. Can handle larger throughput. Disadvantages, it says locked into the hardware. I mean, you got to buy this hardware and it does this job. And, I was talking to someone the other day about, buying some new stuff. And I don't know about you guys, but this stuff changing so fast lately. I mean, every day you look, everything's brand new. It's like, wow, there's a new this or new that or the new next thing on the market. So when do you buy? So, one thing they have not fixed yet, which I have not been able to find one. You know what a level is? Like a torpedo level? Those of you who've done some woodwork, you know what a torpedo level is? Okay. One day I bought one. I was actually using it for many years, actually. And I was always wondering, man, that picture was crooked. And I was installing a catwalk in my house, a very long, 15-foot catwalk using this level. I'm looking at it, I'm like, I got the level out, it's perfect, but it wasn't level. So it finally met, it was not level. And so it was a Craftsman. I like Craftsman tools. Went back to Sears. I'm like, this level is not level. And they're like, sorry, yes it is. So they're like, they put it on their desk. Sure enough, it wasn't level. So they're like, we've never seen a level that's not been level. And that one literally was not level. So they gave me a brand new one that was level. It was like, I went home and checked. All my stuff is crooked now. It's like, oh. Literally, that catwalk is still crooked. It's like,
You never fixed it.
It's kind of good because, the way the cats have like a runway, they can launch off it. But why don't they have digital levels? And we have levels built into our phone. They're not very accurate, by the way. But why don't they?
I've seen digital levels.
You have
Like
seen
it's
this?
just its own thing, where it's like it's like with a caliper also.
I want a level, like a torpedo level, a 6-inch long or a foot long level. I can put it on the board and it's going to tell me 0.01. Because, we got that bubble in there. Come on, you can be off a little and that bubble still looks like it's in the middle.
You haven't used the laser levels?
I got a laser level. I have one. I can put it on the wall to hang pictures and stuff. But if I'm going to put it on this whiteboard right here, and if I'm going to stick it on top of the whiteboard, laser level, and that's good for that. So, yeah, because that's how I hang pictures. Oh, that thing's amazing, the laser level. But I just want a torpedo level that's digital. They should have those.
I'm sure it's.
I haven't seen one. So when you find one, let me know. That'll be worth 0 bonus points. All right. All right. So hardware firewalls are pretty good. Software firewalls are good because they're, built into something else, maybe into your computer. But, they could get, okay, so I have a software-based firewall on my PC. But if my PC gets infected, obviously the firewall at that point could get infected as well. Okay. Okay, some of the technology involved with it. Network address translation, access list packet filtering. We're going to go through each one of these. Okay. That one, hold on, I got to see this.
I mean, you just go on Amazon digital level and you get like 100 of them.
Really?
Harbor Freight, Home Depot, Lowe's.
I mean, have you looked before?
Yes, I've actually looked. I actually walked through the store and went, why are there digital levels? I have to go look. Maybe they just came out this week.
Oh,
Oh, of course, yes.
Actually, I probably haven't looked for a couple months, but, it's...
What's going on?
We're talking about digital levels. I can't find one. Now these guys are telling me they sell them everywhere. So I need to go back to the store and look for one. Okay. All right. Back to the topic on hand. Network address translation. We pretty much use that, like at the school here. If I was to go, okay, do you want to know how to check your IP address? Well, how do I check my IP address? Exactly. IP chicken.
That's one way. There's a lot of ways.
Yeah, there's what's my IP address? There's a bunch of them. But IP chicken shows that my IP address is this. Is that really my IP address? Well, let's find out.
It's like a network address.
I'm pretty sure my IP address is 10.55.10.86. So why is it not the same? Y'all see that? IP chicken say I'm 164.58.104.12. My computer says, I'm 10.55.10.86. The reason is network address translation. Okay, well, not all, but at one point it was all. But now the majority of computers at Rose State connect out through a single interface. My packet heading out to Google, or heading out to IP Chicken a second ago, hits Rose State's firewall, and the router says, hey, I'll go get that for you. And it replaces the destination address of IP Chicken with itself, sends it out to IP Chicken, then IP Chicken sends it straight back to the router, then the router replaces the source with me and sends it to me. It has a translation table mapping internal to external addresses. Internal private addresses are mapped to public external addresses, which is good. According to the world, we have one address, but we could have thousands.
Network address translation is usually one-to-one, but port address translation is...
No, network address translation is normally one-to-many.
What's the difference
Yeah.
between that?
Well, port, okay. What if Rose State, okay, here's an example. I have my solar system in my house. For years, I would manage it from here, okay? The interface accepted connections on port 80. That's it. But Cox would not allow a connection to my house on port 80. Or was it, whatever, it was a port 80, whatever. Whatever the port was, they wouldn't allow it. So what I did was I told my router, I'm going to connect on 503. So from here, I would connect to my house on 503. Then my router would translate 503 to 80 internal. So it's the external address, the external port going to a different internal port. Okay?
Okay.
Yeah.
I mean, it says allows thousands of internal IP addresses to be mapped to one external IP.
It can do the same thing, but at different ports. Like you have this, okay, another example, Tinker Air Force Base. For the longest time, I think it's different now, it was us.tinker.af.mil. If you went to :552, which was port 552, it routed you to a specific web server for the 552nd. If you went to :752, it routed you to port 752. So using the same address, same IP address, but at different ports. So it's good. It's not a problem, but a lot, like my water sprinkler, I think I showed you all in this class or the other class. I had a port address translation set up for that. But now it's got a cloud-based link, basically. My system talks to them, and then I connect to the main system, and then it translates straight through, so I don't even have to allow a hole in my firewall, which is kind of nice. So, yeah. Very similar, but the NAT is basically just an IP to an IP, one-to-many. The port is, again, one-to-many, but can translate ports as well. Okay. So access lists, they can filter on source, they can filter on destination, they can filter on ports or protocols or services or all kinds of different things, or even connection status. That was one of the biggest things I had when I was configuring mine. I had an issue connecting up passive FTP traffic. Because FTP has like port 20 for the control port, and I think 21 for the data. It's been a while. I think that's what it is. It's one or the other. And then passive actually did something else. Passive actually used an established command. Basically, once you establish the connection, so it was a little bit different. Okay. Again, you can connect in the same way. Now let's talk about packet filtering. You can screen packets based on all kinds of stuff, based on specific protocol, specific address, specific port, whatever you want. Okay. Now, stateful. It says record session-specific information. This one's a little bit different. Okay. What if we don't want to let anything in the row state? See, if we have a packet filter row state, we can say, okay, all traffic coming into row state, going to the specific address where this specific port is allowed in. What if I don't want that? Because it's actually a vulnerability to think about. If we have a hole open, that's a vulnerability. Stateful firewall doesn't let anything in. But if there's an established connection, it will allow returning traffic to that connection. So it's a lot better. It says there's a state table. It relies on spoofing, and it basically lets it. If you already have a connection, it allows it to return. I think there's a picture coming up here with it. Yeah, here it is. So we have a source IP address in the port, and the destination in the port. The connection's established. It'll let the transaction happen. If not, it will not. Pretty basic. Then we got the same thing for application. It'll let specific applications do it. It says inspect network traffic at a higher level, at the application level. Maybe I'm going to allow email or web traffic, but I'm not going to allow something else. So. All right, implement and it says place in between your internal and your external address. Use a demilitarized zone. We're going to see what that talks about. Demilitarized zone, they say there's a small network that maybe you allow stuff through the firewall to it. Maybe that's where your web server is hosted, your email server is hosted. So they're behind a firewall, but you have something, you're going to let some traffic through, but not all of it. Okay, so you get some security, and normally between that and the internal, there's another router or firewall as well. Sits between the internal and so. You basically have the external, then the DMZ, and then the internal. Okay, I think here's a picture of it. So we have the external, the internet going into a DMZ, then our firewall to the internal network. Okay, and between the DMZ and the internet, you still have some sort of filtering. Maybe, if we have a web server, an email server, we're going to allow port 80 and port 25. We're just not going to let the entire world through there. Okay. All right. There we go. There's the additional firewall. Maybe they have it there somewhere. Okay. All right. Adaptive security appliance firewall. Cisco does this. It's the newest way of doing it. PIX, actually Cisco bought out PIX, I think, years ago, and they had a different command set, which was kind of weird. It's just a newer way of doing it. Modular functions. You no longer have to remove and apply your access list. It does intrusion detection. It does detection. It does lots of different things. Okay. Here's what the prompt looks like. And you got the question mark for any help. Okay. After you're entering it, you can do this. This configuration is the same. You can type configure terminal or configure T or even config T and it'll work. You type enough letters to know, so it knows what specific command, then you just don't have to check the rest. I don't know why they're actually showing those commands, but okay. Let's see, the Center for Mission Security. There's a lot of websites out there where you can find a lot of information about best practices and how to configure all this stuff. Or just type it in Google. It's pretty easy to figure out. Okay. All right. Red Seal is another organization, security risk and mapping tool. Just lots of different places. See, they're kind of outdated by the time you look at them from here. And this is Red Seal. This is showing you all the different places. Okay. Okay, monitor your devices. They talk about IPS and IDS, or IPSs and IDSs, intrusion detection, intrusion prevention systems. Okay, I think they're going to each one here. We have a network one, first of all. A network one is one that sits on your network, monitors traffic, and it looks for, detects. IDS, intrusion detection system, detects something. Intrusion prevention actually can prevent something. Okay. Normally they sniff traffic, send you an alert. They can do stuff based upon those alerts. Okay. You can also have them on host base. That's maybe one on this specific PC or on a specific another computer or whatever. Okay. So the IDSOs configure on how to react, what to do with them. Passive, they just listen and potentially report. So they're sending out an alert, log it. Active can actually send out alert and can sometimes reconfigure if I will block traffic, stuff like that. Okay. All right, it says vendors have started focusing on intrusion prevention systems. Why do you think they'd go from detection to prevention? Anybody? So we've been using detection systems mainly. So why would it be better to switch from a detection to something that actually prevents?
If you detect it, it's already there.
Yeah, it's already there. I mean, so they send an alert. They send a log. Is someone going to read the log? Is someone going to get the alert? I don't know about you guys, but when I go to bed at night, my phone's on silent, and I don't answer. Unless it rings nonstop, people know that if there's really important, you just keep calling me continuously. I'll finally pick it up. It's driving me crazy. But, I mean, what if it's something bad? So an IPS can react on that information. But I'd make sure you have some specific rules on what to react to. I would just freak out. Like, can you imagine a mail system that, I saw the word love, for the I love you virus, and just delete every email that says we're loving it? That would probably be a bad reaction. Okay.
Especially on Mother's Day.
Yes. So the most capable of stopping malicious traffic, we talked about that. They can operate at the OS level. Okay. Anomaly Base, they're looking for specific anomalies. Use as a baseline of normal activity and look for something different. Okay. When I converted my access list for my house, I originally set it up based upon a friend's ISP. A guy who ran an ISP. He gave me his configuration, and his plan was to allow everything in and block the bad stuff. Kind of like this. It's an anomaly, but block the bad stuff. The problem with that is you don't know what the bad stuff is. So I converted mine to block everything but allow the good stuff in. But before I did that, for about a week, I created a baseline of what my traffic is. So I looked at my traffic for the week to see what I was receiving as traffic so I would know what good traffic was. Because I had thousands of paying customers. I'm not going to just, do this and, sorry, dude, I totally forgot to log your website in. That would suck. So, and I'll tell you, out of all my clients, the only one I messed up, Bill Richards, is the guy who teaches Unix Linux. I used to host his server for free. And he happened to be out of the country that entire week. Now, his server worked fine. But when he remotely tried to get in from home using a different protocol, wasn't allowed in. Called me, Ken, something's wrong. Can't get into my server. I'm like, dude, you been around last week? No, I was gone. Oh, that's why. Because I didn't have, my baseline was of normal activity, like it says here. It was not quite complete, but it was pretty darn close. Okay. All right. But these can, Anomaly Base can look at your baseline and say, hey, this is not quite normal. This is something out of the ordinary. So kind of cool. Web filtering and filter based on web traffic, and we're seeing more and more stuff like this. DNS filtering. It can block specific domain names. But, you know, the problem with web filtering and DNS filtering and all that is they're going to go around it. Like, try filtering out an email for Viagra. I tried. It's nearly impossible. Because, okay, you go for the word Viagra, then you put a capital V, then you put a lowercase v, then you spell it wrong, and then you put a picture of the letter V, then you spell it bad. But our minds can still read the word Viagra, but it's hard to tell a computer to detect all the different ways to spell Viagra. So that's why we still get some spam emails. They do their best, but it's hard to get everything. Okay? So, web filtering is commonly, attackers commonly target devices allowed access through the network automatically. User workstations get individual users to visit a bogus website or install malicious code. Email attachments like Tinker. I mean, you can't even have can't download an executable of Tinker at all. You can't connect to Google Drive or any cloud-based services at all, which is tough. Can't use flash drives at all. Okay. All right. It says web filtering is used to detect users' attempts to access malicious websites and block them. Spelling error there. I used to work for a company across town, and they had me install a keylogger system. What are your thoughts on keyloggers, legit or not?
Usually not.
Well, the company bought it, and the company told the employees they were monitoring their traffic. I'd say it's legit. I mean, they were paying the bill, so I installed it. But I'll tell you, I mean, I had to show them many times how to read the data. But it was funny, this one guy, they sold stuff. They did a lot of calling. Hey, do you need a pressure washer? That kind of stuff. And this is one of their top salesmen. But he always had his desk. You couldn't see what he was doing. And he was over there working all day long and stuff. So once you put this in, we bring it up and find out he's surfing porn all day long. And so they were freaking out. They're like, he's doing what? I'm like, I'm just telling you where he's going. So they bring him in there and say, what are you doing all day? Oh, I'm on FedEx and UPS and reporting shipping information and all that. What about this porn site? So, you know, just good reasons for it. But, you know, it's that kind of it was a shady company. Like the father of the family was banned from owning a company in Oklahoma. So what's that tell you? So it's owned by all his kids, but he still runs it, even though they're technically the owners. It's like one day he came to me, he's like, Ken, I need a new scanner for the office. Okay? Buy me 2 of them. I'm like, okay. They bill me for 1. What? Yeah, buy me 2. They'll bill me for 1. I'm like, he says, you know, just double the price. Just bill me for 1. What it is he took 1 home. So I brought 1 to the company at double the price, which they didn't care what the cost was. Then he took the scanner home. I mean, the whole family was like that. It was like, hey, the company's getting brand new computers today. So their home computers all got upgraded, and then their home computers came in and put into the company. So that was tough to work at that company. So it was tough. Yes. So, you know, I kind of, you know, when I ran my business, obviously I bought myself computers, but I was the company. I mean, it's, you know, so, all right. Security Operations Center is a permanent team whose members are responsible solely for security response functions. So when I ran my own company, do you think I had a Security Operations Center? No. No. Now, I'm thrilled to death. Rose State actually has the dude who handles the risk guy who handles the tornado watches and were y'all here when they had tornado watch last week? Then they recalled it. Y'all probably got the text message. They had a tornado watch for a tornado that's touchdown in Chickasha. Wasn't even close. So we all went to our shelter. Then they recalled that. I'm like, whoever called that one and screwed that up. But, you know, at least we got something. So, yeah. All right. So, yeah, but they normally manage it. On larger companies, they do have those. Okay. Okay, they leave by indicators of compromises, artifacts left behind by attacker, which indicates someone was there. maybe deleted log files, stuff like that. Just anything you could think of. That's why in a lot of forensics projects, I try to make you think differently. Because in the real world, you're going to find that stuff. It's just not going to be straightforward. Okay. Let's talk about honeypots for a second. Those are machines that are placed out there to appear as if they're vulnerable with lots of stuff in them that you can use to trap people. It's kind of like in my house. If everything's locked up except the front door, where do you think they're going to break in? The front door. So they have a fake front door. They break in the fake door and they don't get into it.
And we have a man trap.
Yeah, we have a man trap, exactly what
Right
it says.
extension.
All right, so a honeypot is configured to place on a network perimeter, configured to have vulnerabilities in it, maybe not updated, stuff like that. The main goal is to distract them from your other legitimate networks. Keeps hackers connected long enough so you can see what the heck they're doing. So the connected honeypot, you should be able to track them from there. They appear to have important data, sensitive information on it, could store fake financial data, could store all kinds of other information. They also have virtual ones, run virtual machines. All right, that's the end of this chapter. All right, it's a pretty short one. So, all right, that's the end of chapter 13. Stop this, or whatever the chapter